Talking about the 3, 8, ready, set, and the go. I hope you're doing well. We are given a plethora of numbers and we have to put them in order from least to greatest. Seems easy enough, right? 10 to the third power, some big number. Square root of 100 is going to be 10. This is going to be approximately 7 because 2 to the 7th gets you pretty close to 100. So just as a quick estimate, it's going to be approximately 7. 100 is 100. And just because I know this, 2 to the 10th power is 2000. It's like 1024. So from least to greatest, let's do this. 7's obviously the lowest. Then we're going to hit 10, which is B. We're going to then hit D, which is 100. And then we hit these large exponents, so E and then A. So in that order, from least to greatest. Capiche? I'll give you a moment to try 2. Take a moment, evaluate these if you can. If you were wearing your thinking cap, probably evaluated these and got 1/2, -10, -3, 0 stays at 0, and -2. Capiche? So lowest one is going to be B. You then hit C, which is -3. We're creeping out of the negatives with E as -2. We then hit 0, and then we creep into the positive realm with A. So there you go. B, C, E, D, A. I'll leave 3 and 4 for you to try. Let's shimmy on down. What else do we have here? Refer to the given graph to answer the questions. Insert greater than, less than, or equal to in each statement to make it true, not false. Okay. So here we're evaluating f of 0 and g of 0. So this is going to be f of 0 has 2. So f of 0 is 2. G of 0 is 0. 2 is obviously greater than 0. So we say that f of 2 now. However, we can't really see it, but we do see that as we move towards the right, green, which is f of x, is going to take more precedence than g in blue. So we're going to say that f is going to be greater than g. Capiche? Makes sense? So again, we don't see it happen, but we can assume that green is going to keep on this upwards and onwards trajectory and be greater than blue. So making f of x greater than g of x after approximately, what is it, 1.8-ish. So there you go. I'll give you a moment to try the next few, and I'll give you some answers there and then some explanation. So pause the video, try these out. You're capable, you got this. Okay, so at a quick glance, looking at where x is -1, blue, it's g of x, it's definitely greater than green, f of x. So lo and behold, f of -1 is less than g of -1. You see something similar here. So again, you might have to look at different parts of the graph. Key ingredient here is that you're assessing f where x is 1. So that would leave you this 0, this x-intercept. And g, you're assessing at -1, which is going to be here where x is 1, or when y is 1. Capiche? Makes sense? You can't see much further down the way. So this is really just assessing, do you understand how green is going to be higher than blue as you move towards the right from approximately 1.8-ish. So that obviously makes f greater than g at that point and less than for 10. Capiche? Comments, questions? You must have a bunch for me. Maybe ask me sometime. The set, this was big from the classwork. I might even do all of these because I think that these are just a good time, but we'll see. I know that one of the roots for this is x equals 5. And why does that help us? Because we've seen in previous videos from synthetic division, if I now write my root here and then write my coefficients of 1, -13, 50 dose, and -60, this will help me figure it out what my factored form is going to work with. Sometimes you can factor this further, sometimes you can't, but this is pivotal to see what the rest of this factored form could look like. So drop the 1 like it's hot. 5 times 1, it's going to be 5. Negative 13 plus 5 gets you to negative 8. 5 times negative 8 gets you negative 40. 12 appears. 5 times 12 is 60. Negative 60 plus 60 is 0. So why is this helpful? Because we know we have a remainder of 0. We have a constant of 12. We have a negative 8x. And we have an x squared as part of our quotient. Because really this was using synthetic division. It's a lovely tool to call upon. I hope you use it more and more. It does save you a lot of time. And so you probably get to this quotient and you think, all right, I'm done. I'm just going to write that as part of my factored form. I mean, you could, but you're better than that. Come on. Look at this. You can definitely factor this further. So think factors of 12 that add up to negative 8, negative 6, negative 2. So really, you can rewrite this as x minus 6, x minus 2. If you don't believe me, FOIL this all out. Should get you back to x cubed minus 13x squared plus 52x minus 60. Capiche? X minus 2. And we'll also give respects to our roots 6 and 2. Capiche? Makes sense. All right. So 12 doesn't give us as much background information. This is just the equation we're given, nothing about the roots. However, there are 4 terms, so shot in the dark. Let's try factoring by grouping. So greatest common factor here is x squared. If we did this correctly, x plus 6 should be the other binomial that's here, making our greatest common factor here negative 11. So the factored form would take our greatest common factors, make its own little binomial. And then how many times do you think we need to write x plus 6? How many times do you think? This is a pivotal step, so I'll even make a note of this. Right, x plus 6 just once for the factored form. So pivotal. I see people write x plus 6, x plus 6. It's just used for the factoring by grouping, but you only need to write it one time when you're boiling down what the factor form is going to be. So you might get here and think, well, that looks about right. That looks okay. But I know this is mean, but this is a difference of squares because it's x squared minus some term that's really being squared. So this is not nice, but they do it, and you're actually totally capable if you just acknowledge that this is x minus square root of 11 and x plus square root of 11, and also an x plus 6. Okay, capiche? So now we actually do see we have 3 roots here of square root of 11, negative square root of 11, and also negative 6. And this is our factored form here. And the key ingredient here was that this was a difference of squares. This had to be taken further because you know what you're doing. Capiche? It's a factored form. It's all this. Okay. You know what? Try this one using synthetic division. Set it up like so. Throw in your coefficients of this 1, 17, 92, $1.50. I'll give you a moment to try out that synthetic division interpretation. So if you did this correctly, your synthetic division would produce a quotient like so, and you might think, oh, I'm done. And in a way you are, I'm not gonna lie, because you can actually say that your factored form is gonna be just x plus 3 and then x squared plus 14x plus 50. However, you have an exponent of 3 and you only have one root. So you need to make those other two roots appear. You can try to do factoring or factoring by grouping if you think that's what you do here, but you don't. So you got to use the quadratic formula to get a hold of what these other roots are going to be. All right, you ready for that? So I'll actually give you a moment. I'm gonna take a moment to sketch out this arithmetic for you, but I will leave you the quadratic formula here. Try to plug in the numbers that are here, get it done. You'll have two roots that are going to be complex, and I'll show you that work in a moment. All right, so hopefully you braved quadratic formula and you got some arithmetic that looks like this. Negative b is negative 14 plus or minus square root of 14 squared minus 4 times 1 times 50, all of that divided by 2. This arithmetic in the radical will boil down to negative 4. It's negative, so you're going to have to use an I term. Square root of 4 is 2. I already rewrote negative 14 over 2 to just negative 7. And then 2i over 2, it's just I. So lo and behold, you have two roots here, negative 7 plus I, and also negative 7 minus I. And I guess if you really want to do it, is that something you could do? Yeah, all right, fine, I'll write it. You could rewrite this as x plus negative 7 minus I in parentheses, and also x minus parentheses negative 7 minus I, like that. If you want to do that, go for it. Some people would say that this is just the factored form, but I guess if you're more in need of seeing three roots, you could do something just like that. Capiche? What can you do here? This is going to be one I'm going to hand over to you and let you try out on your own. So use synthetic division. Use 1. Use 1 from here, and negative 6, and 3, and 12, and negative 10. I'll give you a moment to solve this completely. You won't have to use quadratic formula, but you will have to be a little strategic with the difference of squares. So I'll give you a moment to try this out.